Hello everyone, my name is Matteo Bianciotto. Welcome. We are here today for the next episode of Next Generation Hydro. The webinar today will specifically look at upgrading pumped storage assets to make them ready for the energy transition. We will look at two technologies, variable speed and hydraulic short circuit. Both these technologies are applicable to pumped storage, pump turbines, and the benefits is to enable them to provide ancillary services while in pump mode. Make sure to follow XFLEX HYDRO, the project behind this webinar, both on LinkedIn, Twitter, and check our website. There you will also be capable of finding an ancillary service matrix, an upgraded version of the ancillary service matrix that will show you how all the technologies studied by XFLEX HYDRO are applicable in order to supply a large palette, a long range of ancillary services. This is how the webinar is going to work. We will first start with an interview of 3 different experts that have been directly involved in the XFLEX HYDRO project, and we will then follow with an open session where all the participants are free to ask questions and create a dialogue with the experts. If you have any questions during the interviews, feel free to drop them in the chat. We will make sure to address them as soon as we arrive at the final session. I would say that now we can finally get started. The first interviews will be with Jean-Louis Drommi from EDF. He's an electricity expert that will speak about the experience that EDF has gathered through the implementation of variable speed on the power plant of Grand Maison. Hello, Jean-Louis. Thank you for joining us.
Hello, Matteo. Thanks for this interview.
You're welcome. You're welcome. I have just a few questions for you. The first one is about what you've been doing on Grand Maison. So when you are pumping and running the turbines of the power plant at the same time, you are in what we call in the project XFLEX mode, which is an hydraulic short circuit. What are the benefits?
Well, the main benefit of the hydraulic short circuit is to be able to operate the pumps together with a regulating power, and therefore obtain what could be called regulating pumping. And this has great value on a grid point of view. And
can I just ask you to elaborate a bit more on what type of services Grand Maison is therefore capable of providing to the grid operating in hydraulic short circuit?
It is now possible to add 2 important services for the grid. So the primary reserve, or so-called FCR, frequency containment reserve, and also automatic frequency restoration reserve, or secondary reserve for grid frequency support. So now these 2 grid frequency ancillary services are available with the units and with the scheme being in overall pumping mode.
Perfect. That's very interesting. That means that at the moment, Grand Maison is capable of storing energy in excess, provided by potentially wind and solar when there is too much, when production is decoupled from consumption, and at the same time provide grid stability service like FCR or frequency restoration reserve.
Yes, exactly. So you are stressing an interesting point here, because when the units are pumping, it is what we would call off-peak hours. Yeah. And during those off-peak hours, the bulk of the power plants which have dispatchable power are off. They are turned off. Therefore, the grid lacks regulating power. And it is sometimes a necessity to keep some gas turbines in operation in order to have the amount of regulating power which is required for grid stability. And thanks to the hydraulic short circuit, then some of these gas-fired plants can be turned off, because Grand Maison is providing the service instead.
Therefore, there is also, we can imagine there is also an associated emission saving in providing these services with a hydraulic power plant instead of the gas plant.
Yes, exactly. maybe it's a bit too early to provide numbers. Nevertheless, we are in the process of counting the CO2 emission savings thanks to these related transfer of services from fossil-fired plants to Grand Maison, which is almost zero gas CO2 emission.
Of course. What type of studies did you have to, from an hydraulic and mechanical perspective, did you have to carry out?
Indeed, because the hydraulic short circuit mode is not a mode that was foreseen for a long duration at the design of the plant. We had to make sure that we would not damage anything within such a large pump storage, because Grand Maison is the largest PSP in Europe, 1,800 megawatt installed capacity. So that's a very large scheme. And obviously, no one at the management would have allowed to operate in a mode that would endanger the scheme. So all the studies that were performed in the first place targeted the safety issue to clear all the questions which would relate with water safety, hydraulic transient issues such as surge shaft level, to be sure that it would not either overtop or intake air, which would greatly damage.
And was it difficult to adapt your power plant to for this to happen?
Well, the adaptation of the whole scheme did not require a great deal of large equipment change, because the bulk of the equipment remained the same as before. The main changes were in the SCADA system, which had to be allowed to launch pumps and turbines together, because it seems a bit awkward to be pumping and turbining at the same station at the same time. So this was in the first place forbidden by the SCADA. And the main feature that needed to be changed was the computer system, with new operating software, new algorithm, which would take full benefit of this hydraulic short circuit.
So just to summarize, we can say that the overall process that enabled you to operate in hydraulic short circuit included some intervention on the software controlling the units and the operation in the power plant on your SCADA system, as well as some test and simulation on the hydraulic components of the plants.
Exactly.
And are you going to apply this upgrade, this type of operation mode, on other plants that you have in your fleet?
The point is that with the XFLEX demonstration in Grand Maison, the demonstrator is part of the overall generating system of EDF, and we can see that it is used on a daily basis. Therefore, it has a value for the grid, which means that if other pump storage scheme can operate with the hydraulic short circuit, obviously without any risk and without any safety issue on a hydraulic point of view, we will provide the management with the necessary information so that they can take their decision. But we do have in mind to at least check if the other PSP of EDF, there are in total 6 PSP within EDF, totaling almost 5,000 megawatt, could be operational with the hydraulic short circuit mode.
Many thanks, Jean-Louis, for this very interesting conversation. Stay with us a bit longer. We will come back to you shortly with some questions from the audience.
Thank you.
Thank you.
I'll be happy and glad to share.
Let's speak now with Filipe Duarte, Director of the Engineering and Optimization of Hydropower Asset in EDP, who will speak about the experience that the company has gathered working on the variable speed project in Frades II. Hi, Filipe.
Hi, Matteo.
Hi, good afternoon. Thank you for joining us.
Likewise, it's a pleasure to be here.
Welcome. It's good. We would like to ask you a few questions about variable speed. The first question I have for you today is, why did you decide to build Frades II so quickly after Frades I? What is the story behind the development of this plant? And why did you decide to implement variable speed in Frades II? What was the main driver for that?
So it's a very interesting story. I don't know if you know, but EDP has a pretty diversified fleet in terms of hydro, and from which we have 9 power plants with pumping. Of course, back in the day in 2005, when we decided to when we finished when we commissioned the Frades I power plant. We were at the beginning of a very massive entrance of wind energy, wind power, and which of course created this need for additional storage ability, and of course, and the circumstances was that the site was very interesting, and so we decided to provide this additional investment with a bigger scale, because Frades II has 4 times the power of Frades I. And of course, we were seeking, and we understood about the technology that was, well, at least in Europe, about to start, which is variable speed. There were already a couple of sites which were already deploying or featuring this technology. And so we started making our analysis, studies, visits, and we've decided it was time, and fortunately we were able to build and create this business model which allowed for us to proceed with the investment in this variant, and making this effectively the first project in EDP with variable speed.
And if you were to describe the benefits that the implementation of variable speed in Frades II has brought, how would you describe them? Could you please summarize them for us and for the audience that is following?
Well, the main benefit, I would have to say, which is the one which provides revenue. And this has to do directly with the fact that we are able to provide the automatic frequency control in pump mode, which is, of course, when we are in pump mode, the prices are low. You are able to provide us services that the competition, which is CCGTs and conventional hydro, will only be able to provide by generating power in a moment where the prices are low. So they will have to incorporate in this market the opportunity costs. We don't have this opportunity cost, so we are in a privileged position to tackle this front. And so this, of course, is the main benefit. It's what provides the and what justifies the investment. The other benefits, of course, there's an efficiency gain, because of course you are able to place the turbine operating in a more efficient mode, and I would say there's this difficult to value benefit, which has to do with the flexibility and the fast response in terms of stability to the grid, which is provided. And this, you can see it, and you can witness this by the goodwill that the TSO has given to this unit, and the way that he sees it, in difference to what was the initial situation, where there was a lot of uncertainty regarding the entrance of this technology in the system.
Yeah, very good. And I think this is great, because what you're saying, it's actually really summarizing the main message behind this webinar today. So it's demonstrating how pumped storage can be a one-step solution to provide 2 most important services that the grid might need, which is being capable of storing excess energy and at the same time providing regulation to the grid. So we are now enabling pump storage to basically do more than what we originally thought it could.
And not to mention that you know that this drive is only about to increase. You know that the needs will be bigger and bigger as we move forward with the energy transition.
Thank you very much, Filipe. This was extremely interesting. Stay with us because soon we will gonna try to answer some of the questions from the audience. So I'm sure there will be a lot of these directed to the experience of EDP on variable speed. Thank you again, and we'll speak shortly.
It was a pleasure. Bye-bye.
We have now heard from EDF about their experience on hydraulic short circuit. We've been speaking right now with EDP about the great work done in Frades II with the implementation of a variable speed machine. We will now have the opportunity to discuss with Christophe Nicolet, Director and CEO of Power Vision, who will help us comparing and contrasting these two technologies and understanding what are the difference and what are the best at. Hi, Christophe. Welcome and thank you for joining us.
Hi, Matteo. Nice to meet you and for giving me the opportunity to exchange with you.
It's great to have you here with us. I would like to ask you a few questions, if you don't mind. First of all, I would like to ask you a question about if all power plant owner can or should consider to improve the ability of their power plant to provide grid services.
Mm-hmm. Yeah, actually, I think it's not really a question. This is a fact. At least in Switzerland, most of the power plant owners are really looking deeply in all the possible options they have to increase their flexibility and to provide more services. Indeed, the primary control and secondary control services has gained in interest in the past 3-4 years, and I think nowadays all power utilities are looking for options to increase their grid services.
And if we need to look back at the two technologies we've discussed today, hydraulic short circuit and variable speed, which one is capable of providing what? Which one is more adapted, let's say, to provide what type of range of these services?
Mm-hmm. Yeah, if we start with the hydraulic short circuits, the main target is to address primary and secondary control by taking advantage of the turbine operated at the same time as the pump. And for variable speed technology, then you could address the classical one, primary, secondary, tertiary control, but on top of that, you could address this specific fast response time, new services like fast frequency response or inertia emulation.
Thank you. That's very interesting. So, grid services you mentioned, are these the only benefits of these upgrade in general?
Yeah, for sure. These two technology enable us to increase the flexibility and provide additional grid services. But for example, variable speed enables to operate the hydraulic machine on better hydraulic conditions, which improve the efficiency of the turbine, for instance, by operating it at a lower rotational speed. And also it allows to adjust the speed to avoid the rough zones, and in such a way it's also possible to reduce the wear and tears.
And in terms of hydraulic short circuit, do you see also other benefits apart for the provision of ancillary services?
I think we have just to be careful that the hydraulic short circuits increase also the number of hours of operation of the turbine itself. So there are some pros and cons. But for sure, the hydraulic short circuit definitely allows to increase the flexibility, not only for the strict services you could provide in terms of primary and secondary control, but also because if you don't allow the hydraulic short circuits, for example, to make the transition from full pump to full turbines, you need to fully stop the power plant, and this may take maybe 30 minutes of electricity market, or at minimum 15 minutes, during which you are not allowed to operate at all. So it's an additional way to increase the flexibility. So it's not direct, let's say, grid service specific, but you increase the flexibility so you have a better placement of your power plant on the market.
And that's very interesting. That's very interesting, because I think that one of those aspects where we still see, if you want, a comparison between the capability of electric batteries to provide this type of flexibility and ancillary services and hydropower plant is really the fact that batteries can switch between being a capacitor, so something that absorbs power out of the grid, and an injector, so provide back that power that was previously stored to the grid almost instantaneously. And with hydraulic short circuit, actually, we enable power plant to operate in a very similar way. We dramatically reduce the time that it's needed to move from being a pump to being a turbine. So between being capable of absorbing power to be capable of generating power for the grid.
Yeah, definitely. I'm fully in line with you, and this should not be underlooked, because definitely it's increasing the flexibility of pump storage power plant to allow faster transition from full pump to full turbine, which needs to be carefully looked at in terms, especially of hydraulic transients, because even though it does not last long, maybe the combination of pump and turbine at the same time, if you have an emergency shutdown at the wrong moment, it may put your installation at risk. So this needs to be carefully addressed.
Maybe I'd like just to bring you back a bit more on the argument of comparing variable speed and hydraulic short circuit. If you don't mind, it would be interesting to understand from a capability perspective what variable speed would enable and what hydraulic short circuit or the XFLEX mode in the case of Grand Maison actually let you achieve. So how we can contrast and compare and help potentially owners and consulting firm out there making the good decision when it comes to deciding what to upgrade for.
Mm-hmm. Let's say the hydraulic short circuit has a drastic advantage, is the fact that the costs are very low. Investment cost, the capex, related capex are extremely low, since it's mostly allowing the unit to operate at the same time in pump and in turbines, so that you could take advantage of the turbine control capability to adjust the input power in pumping mode. So the investment is low, but you need to invest in studies like CFD studies for bifurcation, to perform detailed transient analysis to make sure that the new operating mode does not put the power plant at risk. But there is almost no hardware that needs to be installed. So from the cost perspective, it's definitely extremely interesting. And the main target is to address, I think, mostly primary and secondary control services with existing equipment. As mentioned before, the drawback is increased number of hours of operation of the turbines and possibly a bit increase of wear and tear of the equipment. Now, if we look at the variable speed technology, it's quite different. It requires, either you have it because of the design of the power plant itself required to have it, and then maybe you could further increase the flexibility of your variable speed pump turbines by adding new control services. Or you want to convert an existing fixed speed machine to a variable speed. It's quite different. The conversion, of course, induces significant investment cost, either into a full-size frequency converter or into a full conversion from fixed speed classical synchronous machine to variable speed doubly fed induction machine. But with variable speed, you could address new grid services, or let's say emerging grid services for fast power response, which a classical fixed speed machine cannot address. So with a variable speed machine, you could address the so-called fast frequency response, where response time is expected within about 1 to 2 seconds, and then you are expected to deliver maybe 10-20% of power, nominal power of the machine, so in very short time.
Sure.
And the other market is the inertia emulation, where similarly to primary control, you inject power when there are some grid frequency deviations, and you try to emulate the behavior of a synchronous machine using advanced control techniques. But finally, I would say if you have a variable speed machine, I think it would be also a good idea to look at the hydraulic short circuit at the same time. Because both are bringing advantages, and even a variable speed pump storage power plant could take advantage of using hydraulic short circuit. This will for sure increase the flexibility of the power plant. For instance, typically if hydraulic short circuit is not allowed at all, it means you need to wait that all the turbining units are fully stopped prior to start the first unit in pump, and which induce some constraint in the placement of the energy in the market. And if you allow to have at the same time pump and turbines operating, then you could faster respond or better place your energy in the market.
Sure. It's very interesting. So just to underline this fact that actually the two technologies are not necessarily, we shouldn't see the two technologies as competing ones against each other in order to enhance pump turbine, but to provide, first of all, slightly different advantages with very different capital costs as well. But at the same time, also the two technologies are actually not mutually exclusive. We could perfectly implement both of them at the same time, achieving actually the maximum flexibility of a plant, enhancing any type of, enabling the power plant to be capable of providing any type of flexibility service that the grid might need today or in the future.
Exactly, I fully agree. I'm fully in line with you. They are not exclusive, mutually exclusive, and when there is opportunity to combine them, like it is investigated at Frades II in the demonstrator of XFLEX HYDRO, I think it makes fully sense.
So because we know we are living changing time in the energy markets. The energy markets are changing in order to cope with the transition that is happening out there. There is a drastic change in the way electricity is produced today with deep implementation and penetration of wind and solar. And at the same time, there is also a change in the way electricity is consumed. We see more devices that are today connected to the grid. We see the implementation of electric vehicles. So there is a drastic change in paradigm. What is your vision in terms of how the need for flexibility will change in the future?
Yeah, it seems the global trend in the power network is to reduce the inertia, synchronous inertia available in the power network. And because of the frequency converter connected power generation, such as wind and PV. And indeed, nowadays, they are not providing anymore any inertia. And this reduction in available rotating inertia in the grid will definitely constitute a huge challenge for the grid stability in the future. And I think what we have to pay a bit attention is nowadays we are focusing on some existing markets which answer today's challenges. But tomorrow the challenges might be different, and the services we have today might not be able to solve the issue we will face in a few decades from now. And this needs, in my opinion, to be a bit anticipated. And typically, new control services, fast power injection or absorption that a variable speed machine could provide are, in my opinion, definitely a great asset and great features. And additional control services could definitely be defined to better answer to the challenges of tomorrow, and maybe to design new grid services more in line with the tomorrow challenges.
Thanks. I think what you're saying is very interesting and actually underline how forward-looking is a project as XFLEX HYDRO, where we are testing through various 6 different demonstrators a number of flexibility upgrades. Some of them have already a clear application, as we see, for instance, hydraulic circuit being extensively utilized in Grand Maison to service the French grid and stabilize it and provide that flexibility that today, in this moment, with the characteristic of the grid, is required. But at the same time, we're also studying forward-looking technologies as the SPPS, so real-time optimization, variable speed turbines, hybridization of plant with small battery package that, as today, maybe they seem very distant from, far away from how the power plants are actually operated. But in few years, because how fast the paradigm around us is changing, they could see a lot of application and a bigger interest, let's say, from the industry.
Yeah, exactly. And it looks like that we will need to be able to inject power faster and faster to really adapt as much as possible the generation and the consumption at the same time. And this will definitely be a challenge. And this is precisely where I think variable speed pump storage, together with new renewable energy, could constitute a huge asset through the transition to more green energy.
Fantastic. And also underlines how lucky is the European energy, the overall European energy system in having such a big amount of hydropower already there, available, developed, capable of providing a lot of flexibility. And how important is it actually to make sure that in the future, over the next 20, 30 years, this hydropower plant will not only be refurbished, but will be modernized and hence upgraded using the best technologies up there that today XFLEX HYDRO is actually developing in a very successful way. Thanks to your work and one of the other people in the other companies and the other research institutes part of this consortium. Thank you, Christophe. This was a very interesting conversation. I invite you to stay with us because we will have a few more questions from the public soon that will be directed to you.
Okay, great. It was a pleasure for me to participate. I'm looking forward for the future questions and discussions.